Imagine a world where the ground is alive with fire, where lava fountains soar higher than skyscrapers, and where volcanic eruptions never cease. Welcome to Io, Jupiter's most extreme moon, a celestial inferno reshaped by cosmic forces beyond imagination. Io, the most volcanically active body in the solar system, orbits Jupiter in a realm of immense gravitational forces that stretch and squeeze its interior, fueling a fiery landscape unlike anything else. Its surface is a hellscape of towering volcanic plumes, lava lakes, and relentless eruptions that constantly reshape its rugged terrain. Unlike the icy exteriors of Jupiter's other large moons, Io is coated in sulfur and silicate rock, giving it a distinctive yellow, orange, and red appearance. The intense gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede, generates immense tidal heating within Io, melting its interior and driving the extreme volcanism seen on its surface. This ceaseless activity replenishes the landscape, erasing craters and geological features that would otherwise mark its history, making it one of the youngest and most dynamic worlds in the solar system. The discovery of Io's volcanic nature in 1979 by NASA's Voyager 1 spacecraft was a revelation that changed the understanding of planetary geology. Prior to this, volcanoes were thought to be primarily Earth-bound phenomena, with only Mars and Venus showing hints of past eruptions. Yet, as Voyager 1 approached Io, it captured images of a massive eruption from Loki Patera, a giant lava lake spanning over 200 kilometers in diameter. The discovery of active volcanoes on a moon far from the Sun, driven not by internal radioactivity like Earth's but by the relentless gravitational forces of Jupiter, introduced a new mechanism for planetary heating. This tidal heating not only fuels Io's volcanoes but also plays a role in the potential subsurface oceans of Europa and Ganymede, revealing that the influence of Jupiter extends far beyond its storms and magnetic fields. The sheer power of Io's eruptions can be seen from space, with some volcanic plumes reaching heights of over 500 kilometers, spewing sulfur dioxide into space and even contributing to Jupiter's vast magnetosphere. Beneath Io's turbulent surface, the processes driving its volcanic activity remain a subject of intense study. Unlike Earth, where plate tectonics guide the movement of magma, Io lacks a rigid crust divided into plates. Instead, its entire outer shell is continuously deformed by the gravitational forces acting upon it, generating heat deep within its mantle. The interior of Io is believed to contain a partially molten layer, where rock behaves like a viscous fluid, allowing magma to rise and erupt through the surface in unpredictable and violent ways. The temperatures at some of Io's lava lakes exceed those of Earth's hottest volcanoes, reaching up to 1,600 degrees Celsius. These extreme temperatures suggest that Io's volcanic activity is driven by ultramafic magma, similar to the type found on early Earth when the planet was still young and geologically violent. The constant resurfacing of Io, where lava floods over old deposits and buries ancient landscapes, means that the moon's history is written in layers of molten rock, each new eruption erasing the past. Io's atmosphere is thin and ephemeral, composed primarily of sulfur dioxide gas released from its many volcanoes. It is so tenuous that it would collapse entirely when Io moves into Jupiter's shadow, freezing the gases onto the surface until sunlight returns to warm and release them again. The interaction between Io's volcanic activity and Jupiter's powerful magnetic field creates an environment unlike any other. As Io orbits within Jupiter's immense magnetosphere, it acts as a generator, producing electric currents that flow through the planet's magnetic field, creating powerful auroras in Jupiter's upper atmosphere. The constant volcanic eruptions feed a torus of charged particles around Jupiter, forming a vast, invisible structure of plasma that influences the entire Jovian system. This electrical connection between Io and Jupiter is so strong that lightning-like discharges occur in Jupiter's upper atmosphere where Io's magnetic footprint travels. The interplay of Io's volcanism and Jupiter's magnetic forces makes it one of the most fascinating objects in the solar system, where energy, motion, and destruction are constantly at work. The future of Io's exploration holds immense potential for understanding not only its own fiery nature but also the broader mechanisms of planetary and moon geology across the cosmos. NASA's upcoming Europa Clipper mission and ESA's Jupiter Icy Moons Explorer (JUICE) mission will provide more insights into Io's environment, though a dedicated Io mission could reveal the intricate details of its volcanic processes and internal heat generation. Future probes equipped with high-resolution infrared cameras could map Io's volcanic activity in unprecedented detail, identifying how magma moves beneath its surface and how eruptions evolve over time. Studying Io's extreme geology could also provide insights into exoplanets orbiting other stars, particularly those locked in tight orbits where tidal forces generate immense heat. Io stands as a testament to the raw power of planetary forces, a world where fire and molten rock sculpt the landscape in an endless cycle of destruction and renewal, a living laboratory of extreme geology orbiting the largest planet in our solar system. Io is a volcanic wonderland, a testament to the power of Jupiter's gravitational grip. As we uncover its secrets, we get closer to understanding the fiery forces shaping not just our solar system, but worlds beyond. What other cosmic surprises await? Stay curious, and keep exploring the universe with us.